Hi everybody, this is Mrs. John, just going through the 2022 Level 3 Electricity exam. And just remember, don't write on the crossed or hatched area. Let's get right into it. So question 1 is an AC question. George is investigating AC circuits. He connects a 54 microfarad capacitor in series with a 36 ohm resistor, a 25 volt RMS 50 hertz AC supply is shown in the diagram below. Now if you notice, what I've done is these numbers, I have put a letter. So that indicates the capacitance, this is the resistance, that's your supply voltage, and that's a frequency. Okay, now show that the reactance of the capacitor is 58.9 ohms. So show that question, you always write the formula, substitute, and you get the unrounded answer, and then you round it to what's required. So that gives you an achieved. Next question, calculate the circuit current. So for the circuit current, you need to know what's the supply voltage and the impedance, or that's the effect of the resistance and the reactance over here. So the impedance, because they're 90 degrees out of phase, is square root of r squared plus xc squared. Here's your xc. So you do that and you get 0.362 amps. So if you just got this much right, that's achieved. And if you got everything right, you get a merit. Next part, calculate the phase difference between the supply voltage and the circuit current for the circuit shown on page 2 and state which one leads. So there's two things to do. Now, the phasor diagram is, this is actually, that's the impedance. So the phasor diagram for resistors or impedance actually is exactly equal to the phasor diagram for the voltages. So that is the resistance. Here's your reactance of the capacitor. And so if you complete the rectangle, this is your impedance. And that is the angle that you want to calculate. So this is also 58.9 ohms. So I'm using tan theta. And so tan theta is tan inverse of 58.9 over 36, and that's an achieved. And if you say that the circuit current is always in phase with the resistor, okay, so it leads the supply voltage by 58.6 degrees. And so if you said both of those, you get your merit. Now, next part. Explain how the addition of a suitable inductor to the resistor capacitor circuit with the AC supply can make the circuit resonate, and begin your answer by explaining the meaning of resonance in the circuit. So first of all, resonance is when your circuit current is a maximum. So if you've just said that much, you get your achieved. Now, when does this happen? It happens when the impedance is a minimum and Z is equal to R. Now, how can this happen? Now, since the voltage across the inductor and the voltage across the capacitor are 180 degrees out of phase, they cancel each other. So if you've got this much, you've got your merit. So if an inductor whose reactance is XL and this reactance of the inductor is equal to the reactance of the capacitor, then you get XL equals XC and VL equals VC, so that you end up, so these cancel each other because they're 180 degrees out of phase. So you end up with your supply voltage equal to the resistor voltage, and your impedance is just your resistance. So when this happens, the current will be a maximum and the circuit will be at resonance. So if you said all this, you get your excellence. Moving on to question 2, it's on electromagnetism. David is investigating inductors and magnets. He uses a 1.60 Henry 22 ohm inductor and connects it to a 12 volt power supply. The inductor can be considered as a pure inductor in series with the resistor, so that's what's shown here. So now the 1.60 is inductance, 22 ohms is your resistance. Okay, calculate the circuit current after two time constants, once the switch is closed and the current begins to flow. So once the switch is closed, this is my thinking, the current is going to increase but not immediately. It'll go faster initially and then it'll kind of taper off. So first thing is calculate maximum current. So maximum current is supply voltage divided by resistance. So there you go, it's 0.545 amps, and if you got that much, you got you achieved. After two time constants, because it's a growth curve, so it is I equals I max 1 minus e to the power of negative 2. So you substitute and you get 0.471 amps, and that is a merit answer. What's the voltage across the inductor and the resistor once the current is steady? So once the current is steady, the voltage across the inductor is 0 because it's not changing, and the voltage across the resistor will be the same as your supply voltage, which is 12 volts, and you needed both these correct to get you achieved. Once the current has reached a steady value, the switch is opened and the current falls to 0 in 2.50 times 10 to the power of negative 2 seconds. What's the size of the average induced voltage, and what is the direction of this voltage across the inductor? So the formula for the induced voltage is L delta I over T. So this is your L, delta I is the change in current, and T is your time, and you get 34.9 volts. If you got that much, it's an achieved. Now, what does the voltage across the inductor do? It opposes change. So if the current is falling, it'll try to prevent the current from falling, so it will act in the same direction as the battery voltage. So you needed to say that in order to get your merit. Now, the 22 ohm resistor is now replaced by 44 ohms. Now, the connection between 22 and 44 is that 44 is double 22. So just keep that in mind, okay? Because 22 times 2 is 44. So, and the switch is then closed. Explain by comparing quantitatively, that means how much, the changes that will take place for the size of the maximum current drawn from the circuit, the time constant, and the energy stored in the inductor. So now what's happened? The resistance has doubled. So since I is Vs over R, when R doubles, the current will halve. So you wanted the half, not just decrease, okay, for you achieved. Now if you got that and you said what happens to the time constant, so resistance has doubled, time constant is L over R, so the time constant will halve. Now the energy stored in the inductor is half Li squared. Now the current is halved, so the energy stored will decrease 4 times because it's half times half. Why is it half times half? Because it's current squared. So if you got all this, including the formulae and saying half, half, and 4 times, then you will get your excellence. Moving on to the last question, which is about capacitors and DC circuits. Annie is carrying out some experiments using parallel metal plates to investigate capacitors. She takes a pair of metal plates with an area of 0.160 meters squared, so there's your area, and connects it to a 9-volt DC supply, so there's your supply. Okay. Now the plates are air-filled. That means the dielectric constant for air is 1, and it's separated by a distance of 1 times 10 to the power of negative 3 meters. Show that the capacitance is so much. So again, for show that, you need to write the formula, substitute, okay? That's your A and D, and you get the answer. So always write the unrounded answer first, and then write this. So for doing that, you get your achieved. Calculate the energy stored in the capacitor once it's fully charged. So energy stored is half QV, or that is same as half CV squared. So you substitute, you get your answer. There's your another achieved. Now introducing a dielectric, what's going to happen is that it'll increase the charge stored on the plate 7 times. You've got to get the 7 times to get your merit. If you just say it'll increase, that's only an achieved. So the energy stored in the capacitor will also increase 7 times. Moving on, Annie then disconnects the plates from the 9-volt DC supply so that the plates are electrically isolated, and she pulls the plates apart, what would happen to the charge and the voltage across the plates? Now, because it's electrically isolated, the charge is not going to go anywhere. Isolated means it's not connected to anything. So the charge on the plates will remain the same. Now, because they're pulled apart, the capacitance will decrease. Why? Because capacitance is mu 0 mu r A over D. So if D increases, capacitance decreases. Now, since C is equal to Q over V, Q is the same, C has decreased, so what's going to happen to the voltage? The voltage across the plates will increase. And then this one here, what's the voltage? So this, in this diagram, what's the voltage across this capacitor? Okay, so first of all, what's the total capacitance? So you've got these two in parallel, and that's connected with this in series. So you get one value for capacitance here. In parallel, you just add them up. So it's 600 and 200, you get 800 microfarads. And in series, you got to do the 1 over formula. So you get the total capacitance, and then you get the total charge. Okay, so charge is C times V. So that is your C times V is the supply voltage, and you get your charge. Now the voltage across that capacitor V is Q over C. So this is the charge, and that's your capacitance, and you get 7.56, and that's your excellence. And that's this paper for you.